Day 11. This video is all about functions and the vocabulary and notation that goes along with functions. For example, number one, domain. The domain of a function is the possible x values that are covered by a function. And so of course the x-axis is going from left to right. So we will look left, right, and ask ourselves how far left does it go and how far right does it go. And even though there are no arrows on here, we're supposed to assume that this keeps on going based on the way it runs off the page. So the domain is going to be negative infinity to positive infinity because the graph goes left and right forever. On the other hand, the range is the y values covered by a graph. The y values of this function, so we're asking ourselves how low does it go and how high does it go. Alright, the range will go from bottom to top, and it has to be in that order, always least to greatest. Now this graph goes down forever, so down forever is negative infinity. So from bottom to top, we're starting from negative infinity. But it does have a top. Okay, the maximum value reached by this graph is right here. Okay, and it is at, let's see, so this is 1, 2, 3, 4. Okay, so that's the maximum value reached by this graph is at 4. And we will use a square bracket to include that 4 because it does hit 4, it reaches it. Alright, so that would be the range, bottom to top, negative infinity to 4. Now, the end behavior. So we're asking ourselves what happens on the left and what happens on the right. Well, on the left it falls, and on the right it falls. But we need to write that using the proper notation. So instead of saying on the left, we say as x approaches negative infinity. Okay, that basically means on the left, approaching negative infinity. And then we're supposed to say what happens to the function. So f of x approaches. So we're saying on the left it falls. So in other words, on the left the function approaches negative infinity. Alright, but this basically means on the left side it falls. And then on the right side it also falls. But in symbols, to say as we go to the right, we say as x approaches positive infinity. And you can just say as x approaches infinity. And then again, we're supposed to say what happens to the function. So as we go to the right, in other words, as x approaches positive infinity, the function goes down. So f of x approaches, again, negative infinity. So all of this is always going to be the same, except for the end part. It's always going to say as x approaches negative infinity, f of x approaches. It's always going to say as x approaches positive infinity, f of x approaches. All that's going to change is what happens on the very end. And if it's going down and down forever, we'll put negative infinity. If it were going up forever, we would put positive infinity. Alright, the x-intercepts. Remember the difference between x-intercepts and zeros. The x-intercepts will be ordered pairs, and zeros will just be numbers. Okay, so the x-intercepts are here, 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 and here. I'm noticing that some of these are between the lines, so estimate with decimals. Alright, so this x-intercept seems to be at negative 6, 0. Okay, and this next one seems to be at, let's say, negative 0.7, 0. Alright, this one seems to be about 1.3, 0. And this one seems to be about 5.3, 0. Okay, and of course the zeros are just the x values themselves. So these are the x-intercepts. Now I'm going to list the zeros in blue. Alright, I don't know if I can fit them, but the zeros are just -6, -0.7, 1.3, and 5.3. Okay, the zeros are just the numbers, and the x-intercepts are ordered pairs. Alright, now the y-intercept will also be an ordered pair, and it seems to be very, very close to 0, -1. Alright, so I'm just going to go ahead and put 0, -1. Alright, now the maximum value is, when we talk about maximum and minimum, we are talking about y values. Okay, so the maximum value of this graph occurs right here, but it's the y value that we want, so this is 4. So the maximum is 4. The minimum value would be the lowest value hit by the graph, but this graph goes down forever, so there is no minimum. Okay, now where is the maximum? If I ask you where is the maximum, I'm asking you for the x value. So the maximum value occurs at this point, but it has an x value of -3. Now if I say where is the min, well, there was no min, so I'm just going to put no min. Okay, let's look at the next one. The domain. Again, the domain is how far left and how far right it goes, because the domain is all of the x values included in a function. So in this case, once again, the domain is -infinity to +infinity, because it goes left and right forever. The range is how far it goes from bottom to top, because the range represents the y values of a function. Alright, so the lowest value hit here is -4. So we're going to do -4 to infinity. Okay, bottom to top, -4 to infinity, that's the range. Now the end behavior, on the ends, it rises in both cases. So that's, it's going to go to infinity and infinity. Alright, on the left it rises, and on the right it rises. So the end behavior, you know, I could literally cut and paste the end behavior from the previous problem, because almost everything is going to stay the same except for the last little bit. Oh yeah, I got it. Okay, so there I just cut and pasted the entire thing. But so this means on the left the function, now before we said it falls, alright, so -infinity both times, because it fell on the left and it fell on the right. In this case, everything's going to be the same, except for at the end, instead of falling, it rises on the left and the right. So all I really have to do is erase the negative signs. And now it says, as x approaches -infinity, the function approaches +infinity. In other words, on the left, it rises. As x approaches +infinity, the function approaches +infinity. In other words, on the right, it rises. Okay, so I hope you're getting that most of this is going to stay the same all the time. So you can just focus on these two bits on the end. Does it rise or fall? Will it be +infinity or -infinity? Okay, there are other options. There's something called an asymptote that we're going to learn about later in the year, where the function can get closer and closer to a certain number. So that's coming, but for now, this is what we've got. The x-intercepts, we'll start with that. Listing these x-intercepts as ordered pairs, because that's what x-intercepts are. we've got 1, 0, and 5, 0. Okay, so that's how you would write x-intercepts. Now the zeros, okay, are just the x values. So if I want to say the zeros, I will just say 1 and 5. All right, simply listing the x values. The 1 and the 5 are zeros, 1, 0, and 5, 0 are the x-intercepts. The y-intercept seems to be 0, 5. All right, because that is my y-intercept right there. And again, the y-intercept is always an ordered pair. Now the maximum, all right, this graph goes up and up forever, so there is no maximum. But there is a minimum. The minimum value is right here. And if I ask you for a max or a min, I'm asking you for a y value. So the minimum value is -4. Now if I ask you where, I'm asking for an x value. Where is the maximum? Well, there was no maximum, so I'm just going to repeat that. No max. If I ask you where is the minimum, though, you can tell me. Because this is the point 3, -4. The -4 is the minimum value. The 3, the x value, is the where. So we have a minimum value of -4, which occurs at an x value of 3. That's where it occurs. All right, 3 over. Okay. And now basically we have some review problems here. So we're supposed to factor this completely. Now remember, the first step of factoring is to look for the greatest common factor. So if I pull out this 2, then what I have is x to the 3rd power plus 27. But then you must recognize that this is the sum of 2 perfect cubes. And so the way you do that is this will always factor as a binomial and a trinomial. The binomial, I feel like I'll switch to red. The binomial is just going to be the cube root of each of these. So x to the 3rd power comes from x. Okay, we'll bring down the plus. 27 comes from doing 3 to the 3rd power. So there's your binomial. Now, to get the trinomial, the beginning and end come from just squaring these. So if I square x, I get x squared. If I square 3, I get 9. All that leaves is the middle. The middle comes from multiplying these, but we do the opposite sign. So it's going to be negative 3x. Okay, you just multiply these, but you take the opposite sign. It helps some students to remember if you say soap. It helps with the sign. Same, opposite, always positive. This sign is the same, this sign is opposite, and this sign is always positive. Looking at number 20, it's factor time. 2x squared can only factor as 2x and x. But 12 could be 3 times 4, or 2 times 6, or 1 times 12. Now, there was no GCF in the original problem. And that means there should be no GCF in the factored problem either. Neither one of these parentheses should have a common factor. So that tells me, for example, that the option of 2 and 6 is not possible. I could cross this out right now. There can be no 2 and 6, because regardless of whether I put 2 here or 6, that would be a common factor. They'd both be divisible by 2. Alright, so it's either going to be 3, 4, or 1, 2. And even the 3, 4, it has to be 3, 4. It couldn't be 4, 3, because a 4 here would make a common factor with the 2. Now, inner plus outer equals middle. Inner, I have 3x. Outer, I have 8x. I'm trying to get a middle of -5. That will happen if I have a negative 8 and a positive 3, because that would make negative 5x. So there's my positive 3, and this will make my negative 8. Also, a positive times a negative is a negative, so I know that this is my correct factored answer. Alright, last one. This says solve by factoring. So notice on the previous problem when we factored, we just factored and stopped. Okay, that's because it didn't say solve. Hold on, where are my directions? Yeah, the last two problems just said factor completely. So we factored and stopped. We didn't continue, we didn't find x. This says solve by factoring. Solving means we're going to get all the way down to x equals something. Also, as a clue, this is an equation. All right, equations can be solved. Notice on number 19, do you see an equal sign? Neither do I. What about number 20? No equal sign. It wasn't an equation. So don't go sticking an equation in when there wasn't an equation to begin with. All right, but this time it is an equation. Now to factor it though, we need this to be in standard form. So we need both of these terms to get over to the left. So for example, I'm going to subtract 5x from both sides. So that'll give me so far x squared minus 5x equals 14. But then I'm going to subtract 14 from both sides. Okay, so this is going to give me x squared minus 5x minus 14 equals 0. So there, now I've moved both of these over to the left, and now I can factor very easily. X squared can only be x times x. 14 could be 2 times 7 or 1 times 14, but it's pretty clear that it's going to be 2 times 7. Remember, the middle needs to be negative 5x. Inner we have 2x, outer we have 7x. We can get negative 5 if we have a negative 7 and a positive 2. So there's my negative 7, there's my positive 2. Also, a positive times a negative is a negative, so this is looking pretty good. In fact, it's certainly factored correctly. But we don't stop here. Because we're solving, we keep going and we set these equal to 0. Okay, and subtract here, so that gives me x equals negative 2, and we'll add here, so that'll give me x equals 7. So these would be the solutions to number 21. Alright, and that is the end of this video. I hope it was helpful, and I will see you on the next video.